Hello students, good morning to one and all. So in the today's class, we are going to focus remaining part in the solution lesson. Here you see, yesterday we have taken or we discussed about Raoult's law. Okay, so the solution which contains two volatile liquids. Okay, two volatile components, you can take like that. So different cases we have seen in the last class. In the today's class, what we are going to do is, what is lowering vapor pressure and what is relative lowering vapor pressure, and next one is Raoult's law for the solution which contains non-volatile solute. After that, various forms for that Raoult's law we can see, and next one we can go to the variety concept and very interesting concept, that is immiscible liquids. So these topics we are going to focus in the today's class, right? So first, coming to the first one. What is the first one? You see here, lowering vapor pressure. So all of you put side heading, lowering vapor pressure. Okay, lowering vapor pressure. So what is meant by lowering vapor pressure? Okay, so lowering vapor pressure. So we have to decrease, our vapor pressure will be decreased or reduced. Okay, so just imagine, to understand this lowering vapor pressure, simply I am taking one vessel which contains only water. Water means solvent, you take solvent. So here see, I am taking only water which is solvent. Here you take water, okay, solvent. So like this, it is having some vapor pressure, only solvent, pure state. It is having some vapor pressure inside. So that one I am taking it as like a P naught. P naught is equal to vapor pressure of the what? Pure liquid or solvent in pure state. So just you take it as like, this is vapor pressure. Vapor pressure of pure liquid or pure solvent. Okay, pure liquid or pure solvent. You can take like that. So this is P naught. So this is not a solution. You have to have clarity here. This is not a solution. Just it is a one liquid I have taken. We did not prepare any solution. We have taken liquid. In that liquid place I have taken water. So water will have vapor pressure. So that vapor pressure we have taken it as like a P naught. P naught means what? Vapor pressure of the what? Pure liquid, or you can take it as like solvent. Okay, so now here see, next step what we are doing here is, to this I am adding what? A non-volatile solute. Have you got it what I am saying here? Here you can take simply here, we are adding a non-volatile solute. So these rounds are nothing but spheres. You can consider it as like a non-volatile solute. Here you see this water as usual. To that water I added a non-volatile solute. So this is, these spheres we can consider as like a non-volatile solute. Whenever you add non-volatile compound, what's happening inside of the solution? So then everyone should remember here, whenever you add non-volatile solute, then it is becoming as like a solution. It is becoming as like a solution because it is having solute plus solvent. Solute plus solvent. Have you got it? Solute plus solvent. You can take like this. Okay. So now after addition of the non-volatile solute, here vapor pressure you can take, vapor pressure decreased. So now it is a solution, no? It is a solution. So its a vapor pressure, we can take it as like a PS, because it's a vapor pressure of solution. Okay, here is it clear? Any doubt in this? First I have taken one vessel. In this vessel I have taken water. That's nothing but a solvent. Okay, nothing but a solvent. So in the solvent, it's a vapor pressure. I am taking it as like a P naught. Okay, P naught. So you can take it like this. After that, to this solvent or plus solvent, and it's important point, that is, here you see PS, which means vapor pressure of what? Why, sir? What is the reason, sir? What is the reason behind this? You have to have clarity here. What is the reason? Because you added non-volatile solute. Non-volatile solute. This non-volatile solute never participate. This non-volatile solute never participate in the evaporation process. Never participate in the evaporated process. So automatically what will happen here? They never involve in the evaporation process. They never involve in the vapor pressure, converting into vapor pressure. So automatically vapor pressure decreases. Have you got it? So therefore, just you can take it, how much pressure is decreased. If you want to know, you have to do like this, P naught minus PS. Can you see this? Yeah, P naught minus PS. You can take like this, which is called as LVP, lowering vapor pressure. So take it down, this one, lowering vapor pressure. So reason very simple here, very simple. I have taken solvent, pure solvent in pure form. So it's vapor pressure P naught. To this solvent I added non-volatile solute. So whenever you add non-volatile solute, this whole is becoming as like a solution. Due to addition of non-volatile solute, here those non-volatile solutes are not involving in the evaporation process, because here they are non-volatile and they are becoming as like an obstacle to the other particles which are involving in the evaporation process. So therefore overall vapor pressure of the solution, I am taking it as like a PS, and this PS is lesser than the P naught. Why? Because due to addition of non-volatile solute, and it is occupying some space of surface of liquid, and they are not involved in the evaporation process, therefore vapor pressure decreases. If you want to know how much vapor pressure is what decreased, if you want to know about that, P naught minus PS should be taken. So whenever you take that, how much vapor pressure is reduced, you can find it out. Have you got it? So this is called as lowering vapor pressure of the solution. Have you got it? So lowering vapor pressure, how much lower the vapor pressure of the solution, you can find it out like this. Is it clear? Any doubt in this? You take it once, after that we'll go to the RLVP, relative lowering vapor pressure. Take it down. Is it clear? Right. So now here see, after that, up to here we learn about the lowering vapor pressure. So what is that lowering vapor pressure? So clear. Now coming to the next one. What is the next one? Next one is, next one you can take relative lowering vapor pressure. Relative lowering vapor pressure. So what is meant by relative lowering vapor pressure? Relative lowering vapor pressure means nothing but a relative, or nothing but we can take the ratio of lowering vapor pressure of the solution which contains non-volatile solute to the pure solvent. Simple. You need not to take anything like RLVP. Relative lowering vapor pressure. What can we, how can we take here? Lowering vapor pressure P naught minus PS by P naught. This is called as relative lowering vapor pressure. Which means here everyone should focus. Here you see this. This is lowering vapor pressure. The ratio between lowering vapor pressure and the vapor pressure of pure solvent is considered as like a relative lowering vapor pressure. So these points you should have clarity, because if you want to understand the remaining cases in the Raoult's law, you have to have command on these 2 points. So that's what we started with these 2 points, lowering vapor pressure, relative lowering vapor pressure. So you should have complete command on this. Okay, so now after that, for objective point of view, here either JEE exams or like NEET exams point of view, here you should have a command on this. Here you see this, simply vapor pressure is inversely proportional to the what? Concentration of particles. Okay, have you got it? So here you see next one. After this, lowering vapor pressure directly proportional to number of particles. Can you see this? These are very important. Next one, after this, what can we take here? Boiling point you take. Boiling point, also same, directly proportional to the concentration of particles. Like that. These are the points. So first you should have clarity on these total points. Have you got it? So then we can enter into our major Raoult's law. Is it clear? Any doubt in this? One by one you can go through, step by step you will get complete command on this. Okay. So after this topic we have to go for Raoult's law. So Raoult's law, this is third case. In yesterday's class we have discussed about 2 cases in detailed manner. We have discussed 2 cases of Raoult's law. Okay, so now this is the third case and very interesting, and this is important case also. Okay, so now you can see this. What is that? Same thing, vapor pressure of liquid in liquid. You take same thing, no problem. Liquid in liquid solution. Okay, same thing I am taking here. Okay, but here you should have clarity on one point. What is that? This is just you consider as like a solute. This is considered as like solute. Solute I am taking it as like a B. I am taking it as like a B. Don't forget about this. And this is I am taking it as like a solvent. This one I am taking as like a A. Have you got it? So here the point we need to understand is this solute is non-volatile. This is very important. Solute is a non-volatile. Okay, solvent, here you see, remember clearly I will write here, solute, non-volatile. So solute is non-volatile. You can take like this. And solvent here is volatile. So this is difference, major. Okay, solute is what? Non-volatile. Solvent is volatile. Okay, so in the last class we discussed, here both liquids are volatile liquids. So we applied and we derived 2 equations of Raoult's law in different cases. But here the concept is different. Here see, solute is non-volatile. Non-volatile means no vapor pressure here, simply we can say that. Okay, so here you see this. Then now you have to apply Raoult's law for this. You people all know very well. You all know very well what is that? PA. Raoult's law. Partial vapor pressure of the component A is directly proportional to the mole fraction of A. Okay, you know very well, that is Raoult's law. You people all know. So therefore, PA is equal to, we can write P naught A chi A. You can take like that. Chi-A. You can take. This is Raoult's law. Yesterday also this point we have discussed. But the point coming to the next one, solute is a non-volatile. For non-volatile there is no vapor pressure. Okay. So therefore for this we cannot take. We will take it, or we consider it as like a B is equal to PB is equal to 0, because it is a non-volatile. Don't forget about this, because it is what? Non-volatile. So that's why here this part is becoming 0 and this part is becoming what? Solvent. Solvent is nothing but a volatile. That's why it is following the Raoult's law. Okay. So now after that, what is next point? Next point is, you see here, total pressure of the solution. PT you can write, or PS also you can write. Okay. So PT, PS both are same. Pressure of solution or total pressure. You can take anything, nothing will happen here. So I am taking pressure of solution, or you can take total pressure according to Dalton's law. You already learned in the last class. So what is that? Total pressure, or which is equal to solution pressure, is equal to what? PA plus PB. You know, according to Dalton's law. Now what do we have to do here? Here just you substitute these values. Here it is becoming as like a 0 because it's a non-volatile, and it is a volatile. That's why it is following Raoult's law. These terms I am substituting here. So therefore PS is equal to, what is that? P naught A Chi-A plus 0. You can take these two terms. Now therefore overall step you can see here. Overall step, can you see this? Okay. That PS we can take it as like PS is equal to P naught A Chi-A. You can take like this. Have you got it? So first of all, up to here you should have clarity. Is it clear? Any doubt in this? We entered into the next case of Raoult's law, where the solution contains non-volatile solute. Whenever it contains a non-volatile solute, the partial pressure of the solute would be 0 in the solution. So we have substituted. Finally we got this one. Any doubt in this? So take it down. After that, here see, next step. Now you go to the next step. I am taking this step, where this step, you see here, PS is equal to P naught A. This is P naught A. Okay. So P naught A. Chi-A place I am writing 1 minus Chi-B. I am writing 1 minus Chi-B. You all know very well. Chi-A plus Chi-B is equal to 1. So mole fraction relation. Chi-A plus Chi-B is equal to 1. Therefore, Chi-A is equal to what? 1 minus Chi-B. You can take like this. Have you got it? Okay, so that's what I substituted here. So now what is going on? P naught A minus P naught A Chi-B. You can take like this. Is it clear? Right. Now what is going on here? You see, step by step. This PS is going towards that side and this point is coming to this side. So therefore, P naught A Chi-B is equal to P naught A minus PS. You can take like this. Okay, just this term is coming towards this side and PS is going towards that side. Have you got it? So now here see, final step. Therefore, Chi-B is equal to, or you can see this PA is coming to this side. Therefore, P naught A minus PS by P naught A is equal to what? Chi-B. Okay, so you can simplify like this. That is what? This is what simply say, it's a relative lowering vapor pressure. Okay, so this relation, this part we can consider it as like a relative lowering vapor pressure. It's a relative lowering vapor pressure is equal to what? Mole fraction of non-volatile solute. This is what Raoult's law for This is what Raoult's law for what? A solution which contains non-volatile solute. What is the definition for this case? Here you see, for this case we can define like this. Relative lowering vapor pressure of solution is equal to the mole fraction of non-volatile solute, okay, which is present in the solution. So this is the Raoult's law for the solution which contains non-volatile solute. Don't forget about this. Is it clear? Any doubt in this? All of you take up to here. Next we will go for simplification, okay, clearly. So step by step you can take it down. Is it clear? Right. Take it down. Okay. Next part. Next part you can take this one. Continuation for this. Now here you know very well, chi b means you can write like this. What is that? P naught A minus Ps by P naught A is equal to number of moles of solute. B means solute plus number of moles of solute plus solvent. You can take like that. A plus B. Okay, so this is this expansion we have taken like that. Now what we are doing is very simple. What we are doing is very simple. Here this is, I am taking dilute solution. Whenever you take dilute solution, in the dilute solution number of moles of B when compared to the number of moles of A means solvent. Number of moles of solvent is very high when compared to the number of moles of solute. Therefore, in the denominator, here this value is negligible. Therefore, above formula will become like this. That is P naught A minus Ps P naught A is equal to what? Here you can take NB by NA. You can take NB by NA. Have you got it? So this is the formula you can take like this with respect to what? Number of moles. This formula is what? With respect to mole fraction. Don't forget about this. Here cases we should have clarity. So sometimes while solving the problems they mention with respect to mole fraction, you have to use this formula. Whereas coming to the next one is what? Sometimes they will mention number of moles and they'll ask for relative lowering vapor pressure. So that case we have to use this formula. Have you got it what I am saying here? So we should have clarity on this. Now overall step we can write like this. What is that? Here see, number of moles of solute by number of moles of solvent. So therefore you see here we can write like this. Number of moles means weight by gram molecular weight. So that concept we are going to use here now. P naught A minus Pa, okay, divided by P naught A is equal to, here see, number of weight by weight of solute by gram molecular weight of solute into gram molecular weight of solvent you can take. A means solvent you can take. Solvent by weight of solvent you can take like this. A here you can take like this. Have you got it? So this expression where can we use? Sometimes weights will be given. Weights, gram molecular weights. In that case you have to use this formula. Have you got it clearly? So while applying the concept to solve the problems, you should have command on what type of or which formula is suitable to solve that problem. Which formula is suitable to solve the problem. So that's why you should have command on this. Have you got it up to here clear? So one more expression I am going to give you here. Everyone should have focus on this. Okay, up to here clear? Any doubt in this? Okay, take it down. Okay, done. Is it clear? Now one more excellent expression I want to give you here. Excellent expression. What is that excellent expression? You see. Okay, so up to here clear? Any doubt? I want to give you some limitations for this. Okay, so there are, this Raoult's law has limitation. Okay, which contains. So one by one you see that limitations. First limitation number. Up to here clear? Any doubts? Okay, so if you have any doubt you can ask me in the comment section. No problem. I will give you reply to you. So up to here clear? Now we have to discuss about the limitations. What are the limitations? First one. First limitation. The solution must be dilute. So solution must be a dilute solution, so solution should be a dilute or must be dilute. Solution must be dilute. That is one condition here for this case. In this case, if you want to apply these cases, the solution must be dilute. And next one is, solution must be ideal. What is ideal solution? I will tell you. Okay. Our next class, ideal solution. Solution must be a ideal solution. Okay. So what is that? We will have discussion about that. And next one you can take here, solute should not involve in the association or dissociation. Okay, solute particle, solute, okay, should not involve in the association or what? Dissociation. Association or dissociation. This is one major point. Solute should not involve in the association and solute should not involve in the dissociation. Okay. Next one, solution must be a ideal solution and solution must be dilute. Have you got it? So take it down one by one. If you have any doubts you can ask me. Just you take down. Okay, completed. Right. So up to here clear? Right. Okay. Okay, one more. 4 points are there. One more. You know that fourth point. You know that familiar one. That is what solute must be a non-volatile. For these cases I am talking about. Okay. Solute must be, we already discussed this point but I am mentioning here. Solute must be non-volatile. Non-volatile. So these are the conditions for this Raoult's law. The solution which contains non-volatile solute. Have you got it here? Any doubt in this? Just you focus on. Okay. So after this we are going to focus on one more rule or nothing but one more form. Okay. So here you see that one more form. What is that one more form? See, up to here clear? Okay, done. These are the conditions for the Raoult's law in this state. Okay, so keep it here. I am taking now this one. Okay, so what is this? This case. I am going to give you one more form of Raoult's law. Here see. That means P naught A minus PS by P naught A. P naught A means what, sir? Pure solvent, vapor pressure. PS means what, sir? Solution vapor pressure after addition of non-volatile solute. Okay, so this is whole what, sir? Relative lowering vapor pressure is equal to, here see, this expression I am multiplying with 1000 by 1000. 1000 by 1000 means what? One only, no? So here you see this relation I am multiplying with W weight of solute by gram molecular weight of solute into 1000 by weight of solvent. WA means weight of solvent. I am taking like this. Have you got it? So now here, after that, what is happening here? We have to have clarity. So now remaining part is what? What gram molecular weight of or gram molecular mass of solvent divided by 1000. You see this logic. Same thing. I have taken same thing, but I divided with and I multiplied with 1000 by 1000. You get cancel, again you will get that one. Okay. So these two get cancel, again we will get this relation. Have you got it? So finally what we are getting here, what we are taking is this one. Okay. So now this is what? Nothing but a molality. Molality formula you all know very well. This is molality, small m, molality expression. So therefore what we are taking here is P naught A minus PS. Okay, you can also write here, always we need not to take like this. Solvent vapor, pure solvent vapor pressure minus solution vapor pressure by, you can take A, I am not writing here because you know that. So P naught A is equal to, instead of this whole term, what can we write here? Molality. Molality. You can write molality into here you can take capital M A by 1000. Okay, capital Ma means what? Gram molecular mass of solute. Have you got it? So do you have idea on this? Weight of solute or gram molecule, here see, this is gram molecular mass of solute. WA means what? Weight of solvent. Ma means what? Gram molecular mass of solvent. So this whole part is becoming as like a molality, then this is one expression. Have you got it? Is it clear? Any doubt in this? So all of you take down. One more expression is there. So from this we are going to derive that. First you take this one. Is it clear? So here my intention is just you try to share our videos to the needed students. Okay. So because I am doing some work, so it must be useful for some students or needed students purpose. So that's why try to share our videos with your friends. So make them, okay, to prepare their NEET or JEE exams. So to get nice marks in chemistry. That purpose I am doing all these things. Just you try to share it. Okay. So up to here this expression is clear. Any doubt in this? Very simple. All these things are not mentioning in the NCERT, but you have to have idea to solve the problems. Have you got it? So take it down all these things. Any doubt? Ask me. Okay, done. So after these expressions, nice expressions, I want to give you one more expression which looks like differently. Okay. So up to here, okay. Now I am taking this above expression. I am taking this above expression. You see what we are going to do here. See this one. Here I want to take this P naught A means I am taking as like a P naught because this is pure solvent, means pure solvent. So directly I am taking it like this. Okay. So I don't want to make you confused. Just see, this term is coming this side, this term is going towards that side. So therefore, just can we write like this? P naught A by above equation I am changing like this. Any doubt you can ask me, I will give you reply to you. Okay, is equal to, what is that? Na plus Nb, number of moles of solvent plus number of moles of solute by number of moles of solute. Okay, B. Up to here clear? Now here you see what we are going to do is, here this expression we can write like this. P naught A by P naught A minus PS is equal to, here you can write as, because NB get cancelled, it becomes 1, Na by NB, you can write like this. Have you got it? You can write like this. Any doubt in this? Once you check it. Just I changed it above equation like this. After that, NB by NB is equal to 1. So 1 plus NA by NB I have taken. Okay. This 1 comes this side. So therefore, here you can take P naught A minus, okay, here P naught A minus PS minus 1, because that side plus 1 is coming towards this side, it is becoming minus 1 is equal to NA by NB. Have you got it? So this term you multiply with this term. So therefore what's happening here, that is P naught A minus this term, P naught A plus, this goes this side, no, plus will come, PS divided by, you can take it like P naught A minus PS. This one get cancelled. Have you got it? Is equal to NA by NB, you can take like this. Okay, so overall final expression, not final, just you see this, PS by P naught A minus PS is equal to NA by NB. NA by NB. You can take like this. Have you got it what I am saying here? So therefore, final step, what can we do here? Final step, you see. The final step for this, P naught A minus PS. Again I am writing in opposite. So just twist. So PS is equal to NB by NA. See, this expression is completely changed. Can you see this? Okay. So this expression is completely changed. Any doubt in this once you see. So you can also take like this. Have you got it? So above expression we can take the simplification we have seen already. Those expressions we have seen already. But now you can use this expression also. Have you got it? How did I do? One by one, step by step you see here. Any doubts you can ask me. I will give you reply. Have you got it? So focus on this. First I have taken this one. In this step just I made it like this equation to this one. You know how did I do? Very simple. After that, here see the NB is same. That's why NB by NB is equal to 1. 1 plus NA by NB I have taken. Both are similar. I think you know very well. Simple math. So that plus 1 comes this side. It will become minus 1. So this part is going towards this side. These two are getting cancelled. PS by P naught A minus PS is equal to NA by NB. Overall remaining part I have taken like this. PS by P naught A minus PS is equal to NA by NB. Just you write it in opposite. You know very well about that. So you can take like this. PS P naught A minus PS by PS is equal to, okay, NA by NB. So this expression also we can use in objective purpose. Have you got it? So very important all these things. Just you have to have complete command. So after class once you practice it, all those formulas, how can we get those, where can we use those, like that you have to practice thoroughly. If you practice strongly, then you can answer any question. The points very important. Is it clear? So after this, take it down. After completion of this concept, we are going to focus on one more interesting concept is there. Up to here we discussed about miscible liquids. That means two liquids will mix with each other. So whenever you mix A and B, they mix with each other. They don't have any problem. So for that, all these formulas are applicable. Miscible liquids all are. Have you got it? Vapor pressure of liquid in liquid solutions we have taken yesterday's class and today's class also. But A and liquid in liquid means those two liquids are miscible with each other, which are soluble or which are mingle with each other. Have you got it? So, but the next topic which we are going to take here, that is immiscible liquids. This is very interesting topic, which is immiscible liquid. Immiscible liquid means what? Here liquids means what? If you mix A and B, they won't mix with each other. Okay, so just you can keep them together, but they won't mix with each other. Have you got it? So very interesting topic. Put side heading all of you, take side heading all of you. Immiscible liquids. Liquids or immiscible liquid solutions. You take like this. Immiscible liquid solutions. So before all are miscible liquid solutions. Okay, Raoult's law, case 1, case 2, case 3, different forms, all those. Whenever you mix two liquids, they mingle with or mix with each other. Have you got it? But here not like that. Here not like that. That means two liquids if you mix, but they won't mix with each other. Those A and B together, but they won't mix. Those are called as immiscible liquid solution. Okay, keep it corner whether it is volatile, non-volatile. So volatile, non-volatile we have taken only for miscible liquids. Here we are not going for volatile, non-volatile like that. Just we simply having idea on the miscible liquids. Miscible liquids means two liquids. Okay, whenever you mix together, they won't mix with each other. Have you got it? Such type of solutions, what do we have to do? How can we take their pressures? Okay, they will have what? Partial pressures. Okay, so now you take simply, this is volatile, this is volatile. Both you mix. Those are having what? Vapor pressures. Then what would be the solution pressure? This is the point. Everyone should have clarity on this. You see, here pressure of total, you know very well, PA plus PB according to Dalton's law of partial pressure. According to Dalton's law of partial pressure, we can take like this. Okay, pressure of total is equal to, what is that? PA plus PB. Is it clear? PA plus PB. You know very well about this. But these both are immiscible liquids. Both are volatile. Both are immiscible because one is not mixing with another. One is not depending on other liquid or second liquid. Okay, then what would be the solution pressure? That is the point here. What would be the solution pressure? Okay, so now here I want to tell you is, here see, PA is equal to, formula you see, Raoult's law you know, no? But here see, that is P naught A chi A, P naught A chi A, and here you see this PB is equal to P naught B chi B. You can take like this. Okay, you know that these two formulas you know, but this is not depending on this one and this is not depending on this one. Both are independent. Whenever both are independent, here what will happen? Chi A is equal to 1, chi B is equal to also 1. Why? Because if both are depend on each other, you can take chi A plus chi B is equal to 1. But both are independent to each other. That's what do we have to take here? Chi A is equal to 1, chi B is equal to 1. Because if they depend, you can take chi A plus chi B is equal to 1. Because these are immiscible, both are not depending, automatically here chi A is equal to 1, chi B is equal to 1. So substitute here. Therefore, according to, after substitution of this point, you have to have clarity on this. Why do we have to take chi A is equal to 1, chi B is equal to 1? Okay, so now here you see PA is equal to P naught A and PB is equal to P naught B. Okay, so these two you can substitute here. That is PT is equal to what? Instead of this, you can substitute P naught A and P naught B. Have you got it? So this is the total pressure of the solution which contains two liquids which are immiscible with each other. What a super point. Take it down this one. Take it down. Okay, sometimes they will mention this one, which are both are equal, you can directly substitute. Don't get confused, don't get confused. Be clear in here, be clear. If you apply Raoult's law, here this chi is equal to, chi A is equal to 1 we have to take, chi B is equal to 1 you have to take. Why sir? Why? Because both are independent to each other, they are not mixing with each other. Whenever they mix with each other, then only you can take chi A plus chi B is equal to 1. Okay, in the above cases both are miscible, these are immiscible. That's why story change it to like this. Have you got it? Take it out. Sometimes they won't mention, here also one more excellent point. Sometimes they won't mention what is, how to get PA, how to get PB, P naught A, P naught B. So sometimes you have to get like this, P naught A is equal to NA NRT, PV is equal to NRT, you know very well. NART by V, volume is constant. We cannot change that, okay? Volume is constant. So now here you see this, can we take like this, P naught B, same story, NB RT by what? V, you can take like this. Have you got it? So here these two terms, if you substitute the number of moles and all, you can get it this one. Okay, so sometimes here you see, you take this is equation 1 and you take this is equation 2. Is it clear? So now next step you see, this is very interesting here also. Now here you see this. Now 1 by 2 you take, equation 1 by equation 2. So equation 1 by equation 2 means what? P naught A by P naught B is equal to, what is that? NA by NB. You can take this formula. Have you got it? Right? Because these all are similar, no? VV get cancelled, RT get cancelled, we will get like this. So one more expression we can take like this, P naught A by P naught B is equal to, you can write, no, what is that? Weight of A by gram molecular weight of A into weight of B, okay, B, and gram molecular weight of B or gram molecular mass of B by weight of B. You can take like this. Okay, so these all are what? Expressions in different cases. This is very useful for JEE and JEE advanced, mains and advanced point of view. Have you got it? Any doubt in this total class? Once you check whole topic which we have discussed here. So in the rare cases or in JEE advanced or JEE mains, in typical cases, typical problems if they want to give, they'll choose the concept from here. Have you got it? If you have complete command on these concepts, definitely you can answer question from this concept. Up to here, all cases of Raoult's law, we have finished that Raoult's law concepts. In the tomorrow, we are going to focus on ideal solutions, deviations of ideal solutions. I will give you clarity about all those things in tomorrow's class. Okay, so any doubt in this, you can ask me in the comment section. We will meet in the next class again. Okay, so till then, bye bye.